In this episode, we're going to configure extended IPv4 access controllers. I'll show you how to do it, and we'll talk about the concepts along the way. In this scenario, specific devices on the LAN are allowed to various services on servers located on the internet. We'll be discussing how to configure a named extended ACL, and then how to apply and verify that extended ACL. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 5.4.13 Configure Extended IPv4 Access Control List Scenario 2. I have our packet tracer file open. On the left side, we can see our topology. This is our work area. On the right side is our instructions. The way bottom right is the packet tracer activity window that opens up when you open up packet tracer. Above that, in the majority of the right side, is those same instructions, but in a Word document. In this exercise, we've got some questions to answer in the Word document and allow me to answer those questions and save them. In our topology here, it's a simple network. We have one router, one switch, 3 PCs. And then from that router, we also have an internet connection. Here's our addressing table. In our addressing table, you can see our devices and our interfaces, the IP addresses that are all associated with them. In this scenario, specific devices on the LAN are allowed to various services on servers located on the internet. So what's going to happen is these 3 PCs over here, they're going to be allowed and disallowed different services in the internet here. And how we're going to control that is we're going to place ACLs on our router 1. Down to our instructions. Part 1, configure a named ACL. Configure one named ACL to implement the following security policies. So we got to configure one named ACL to do this, to block HTTP and HTTPS from PC1 to server 1 and server 2. Servers are inside the cloud and only you know their IP addresses. Then the next requirement, block FTP from PC2 to both servers, and block ICMP from PC3 to server 1 and server 2. Step 0, configure server IP addresses. Confirm and configure, if required, the IP addressing of server 1, server 2 from the addressing table above. Okay, let's go ahead and confirm our IP addresses. What we'll do is we'll come up here, scroll up to my addressing table. On PC1, come up over here, open up my desktop tab, open up my command prompt, so that way we can ping. Then we're going to ping server 1 and server 2 from PC1. So we can go ping, and then the IP address of server 1 is 64.101.255.254. As we sit here and wait, looks like the first one had an ARP request happening during the first ping, but the next 3 worked. I'm going to go ahead and repeat that command to make sure that all 4 work. So I hit up arrow once and hit enter. And we have all 4 of our pings back. Let's go ahead and ping server 2. Server 2's IP address is, so I'm going to type in ping 64.103.255.254. Okay, probably have to do an ARP lookup again. Hoping we do. Okay, so first ping timed out because we were doing ARP requests. Next 3 worked. I'm going to repeat the command just to make sure that it was an ARP request, so all 4 worked. I'm going to close this, open up PC2, go to desktop, go to command prompt, and I'm going to ping both server 1 and 2 again from PC2 here. Okay, server 1's IP address is 64.101.255.254. All 4 pings are working, and let's go ahead and ping server 2, which is 64.103.255.254. Ping, oh, I typed in the IP address wrong. Ping 64.103.255.254. And I still typed it in wrong. Oh, okay, so starting over, server 2 IP address is 64.103.255.254. Once I get the right IP address in there, PC2 to server 2 is working fine. I'm going to go ahead and minimize PC2 and open up PC3. In PC3, click on the desktop tab, open up the command prompt app here, and let's ping our servers again. So it's ping.64.101.255.254. All 4 pings are working. Let's go ahead and ping server 2, which is 64.103.255.254. And all 4 pings worked. So PC3 can ping both servers. Takes care of step 0. On to step 1. Deny PC1 access to HTTP and HTTPS services on server 1. And once again, all of these requirements need to be under one ACL. One ACL. A. Create a named extended IP access list on R1, which will deny PC1 access to HTTP and HTTPS on server 1 and 2. 4 access control statements are required. Question: what is the command to begin the configuration of an extended access list with the name ACL? Well, the command here to start that process, we start off with IP because it's part of the IP suite, and then it's access list because we're working with our access list. And now, if we were doing a numbered access list, we could put that number in there and do each ACE individually. But because this is a named one, we go in and basically go into the access list configuration mode. So first we have IP access, and then we put in, is this a standard or extended? We want the extended because we're going to be filtering out on specific protocols and source and destination, where a standard one just looks at source IP address. We want to be able to look at both source and destination and look at the different protocols we can filter out. So we want the extended here. Extended. Gotta spell extended, right? And then we put in the name here. Our name is capital A, capital C, capital L. Once again, these are case sensitive names of them, and they have to match exactly. So our full statement is IP space access dash list space extended space ACL. On to step 1B, begin the ACL configuration with a statement that denies access from PC1 to server 1, only for HTTP, which is port 80. Refer to the addressing table for IP address of PC1 and server 1. And since we're denying these 2 devices access from each other, we're going to actually use the IP address. We're not going to use a network address, so we have a range of devices. We're going to use that specific IP address. And so if we look over here on our diagram, we're going to deny access from PC1, so from PC1 to server 1, which is over here in our cloud. So we have to create our ACL in here. I clicked on router 1. I click on our CLI tab. I make this a little bit bigger, going right to left, because it just lays out the data better. Go ahead, hit enter. Now we can type in enable to get into privilege exec mode. From here, to start our ACL, we're going to have to put in that statement we just typed in, the line above, but we need to be in global configuration mode first. To get into global configuration mode, go ahead and type config T. Then we can start with our access list. And once again, that command here was IP space access dash list. And then we are extended. And then the name of that, once again, it's case sensitive. Make sure it's a capital A, capital C, capital L. Go ahead and enter. Now we can see that our command prompt has changed. We went from global configuration mode where it just had config. Now we are in configuration mode. It says ext, saying we're an extended access control list. And then specifically, we are dealing with an NACL, a named access control list. So our prompt looks like this right now, that we're configuring an extended named access control list. Now we can go ahead and start entering our statements in. And this is where we are with 1B. We want to deny access from PC 1 to server 1 using HTTP. So I typed in the word deny. I'm going to put a question mark, and now it's asking for what protocol are we going to use. It lists out a bunch of protocols, but web traffic is part of the TCP protocol. So it's now deny space TCP, and then I'm going to put a space and a question mark there again, and it's looking for source addresses or the word any or the word host. And once again, because we're matching up one IP address, not a range of them, we can use the word host here. So it is now deny space TCP space host, and then we need the IP address for host 1. We come up here to our table, we get 172.31.1.101. So 172.31.1.101. Put a space in there and a question mark. And now we're looking for destination stuff. We could either have destination stuff or packets. Because we want to filter on the destination also, we are looking at how can we filter it. Instead of a source IP address, we can go to, instead of a destination network, we can actually go to the host, because we're going to match it to that host. So we can use the keyword host. So after we put in the IP address for our PC1, we can then put host, and now we can put the IP address for server 1, 64.101.255.254. Put a space and a question mark, and we can go and look here. This is where we're going to specify the port, the specific port we're looking for. And we want it to be equal to port 80. So we can do port 80 right here. So after our IP address of our server 1, we can type equal, and put a space and a question mark. And now it says we can put a number here. We can either do a port number, or we can do some of the commonly known ones. We could do this one right here. We could do www, or we could put 80 in there. I'm going to go ahead and put 80 this time. So this is what our statement looks like. Deny TCP host 172.31.1.101 host 64.101.255.254 equals 80. So we're going to deny a TCP, the TCP protocol from the host at this IP address going to the destination of this IP host at this IP address, where we're equal to that layer 4 port number of 80. Rolling down, that takes care of step 1B. Step 1C, next, enter the statement that denies access from PC1 to server 1 only for HTTPS port 443. So it's exactly the same as the one we did, except instead of matching port 80 that we did in the first one, we're going to match port 443. What we can do is we could retype it all up. We could retype it all again, or I'm going to hit the up arrow and then just hit the backspace, get rid of the 80, and put 443 in there. And I hit enter. That takes care of step 1C. Done. On to 1D. Enter the statement that denies access from PC1 to server 2, but only for HTTP. Refer to the addressing table for the IP address of server 2. Well, this is almost identical to the statement we did up here in 1B, except 1B was from PC1 to server 1. Here we're going to go PC1 to server 2. What I'm going to do is I'm going to hit up arrow twice in our router configuration window. Hit arrow up once gave us, this is the command we entered in last here. If I hit it a second time, it now takes us back to the one where it was port 40. All I have to do is change that destination IP address from server 1 to server 2. I'm going to scroll up. Look at server 2's IP address, 64.103.255. Now, I'm going to look here and compare the two server IP addresses, server 1 to server 2. First octet's the same. Second octet is a little bit different. It's 101 to 103. Third octet's the same. Fourth octet's the same. So to change IP addresses from server 1 to server 2, all I have to do is make a change here in the second octet. And actually, we only have to change one digit. We have to change 101 to 103. And so since I've hit up arrow twice here in our command line configuration, just left arrow over until you get into that third octet right here of the destination of server 1, and then change it to the IP address, the second octet of server 2, which is 103. And so now that destination IP address should read, okay, got to make sure I do it right. So that second IP address, that destination IP address should read 64.103.255.254, and that's equal to layer 4 port number of 80. That looks good. Go ahead and hit enter. That takes care of step 1D. On to step 1E, enter the statement that denies access from PC1 to server 2, but only for HTTPS, which was, once again, port 443. Now, it's the same as the statement we just entered in for 1D, except instead of equal to port 80, it's going to be equal to port 443. So over here in our CLI of router 1, I hit up arrow once, and that's the one that was going from PC1 to server 2. But it was looking at port 80. We want to look at port 443, so I'm going to hit backspace twice and then type in 443. And so just to confirm, this is going from a source of the IP address of PC1 to a destination of server 2, and we're looking at HTTPS, or equal to 443. That takes care of step 1. Down to step 2. Deny PC2 access. Deny PC2 to access FTP services on server 1 and server 2. So we're going to deny FTP access. FTP layer 4 port number is port 21. And so PC2 FTP access on server 1 and server 2. Okay, let's start that off. First thing is we're denying traffic, so that's the first word. FTP is part of our TCP suite, and we're going from PC2. And so because we're doing just a single IP address and not a range, we can use the host statement. So it's host. Let's get the IP address from our table here. Here's the IP address for PC2, 172.31.1.102. That is 172.31.1.102. Once again, PC2's IP address is 172.31.1.102. Then we put the destination IP address. We're going to do server 1 and server 2. Let's do server 1 first. That IP address, once again, is 64.101.255.254. And we're doing this specific host IP address, so we can put the keyword host and then that IP address in here of 64.101.255.254 and equal to FTP. And once again, FTP is layer 4 port number of 21. Up, and here is the Cisco operating system telling me I did something wrong. I entered in an invalid input detected at the little arrow. Here's the arrow, and it says I have an error right in this area. And if we look here, I forgot the keyword of equal. Now to fix that, what I have to do is I hit the up arrow once, left arrow over to where the EQ should go, put it in the EQ in a space. Now that line should be correct. I'm going to hit enter, and here is the response from the Cisco operating system. Complete silence. No news is good news when you do something good inside the Cisco operating system. Typically, it won't tell you you did something good, but it will definitely let you know, like it just did, when you do something wrong. Okay, that takes care of PC1 to server 1 for FTP. Step 2B here is from PC2 to server 2 for FTP. Once again, if we look at our addressing table, the only difference between server 1 and server 2, which these two access control entries, that's the only difference, is the second octet of the IP address. We need to change from 101 to 103. So back here in our CLI, I'm going to hit the up arrow once, left arrow over to that octet here of the destination IP address and change it from 101 to 103. So I hit up arrow once, left arrow over, whoops, left arrow over and change 101 to 103. So now the destination host IP address is server 2. You can go ahead, hit enter, and no news is good news. That takes care of step 2. On to step 3. Deny PC3 to ping server 1 and server 2. Ping is part of the ICMP protocol. So we need to block the ICMP protocol here. So enter the statement that denies ICMP access from PC3 to server 1. So denies ICMP access from PC3 to server 1. Okay, we're starting with a deny statement. Once again, this is all in the same named access list, so we can just continue going. And we're denying, so we start off with deny. I'm going to put a question mark, and this is where we specify ICMP right here. Previously, we did TCP because we were dealing with HTTP, HTTPS, and FTP. Now we are dealing with ICMP, so we make our change right here. So instead of saying TCP, we now say ICMP. Then we are going to block it from PC3, and we're going to match that IP address so we can use the keyword host here again. And then come up and get the IP address for PC3, which is right here, 172.31.1.103. So I can go ahead and type that in, 172.31.1.103. Going to both server 1 and server 2. Let's do server 1 first. Once again, we're matching that whole 32 bits of that IP address. We're matching that host, so we can start off with the keyword of host. Whoops, got to click in the window, sorry. Starting off with host, and then the IP address, which I just typed over, so I can hit Control Z. It'll put it back here. The server 1 IP address is 64.101.255.254. Go ahead and type that in, 64.101.255.254. And because we're matching everything in the ICMP, we don't care. We're just going to filter out all ICMP. We just go ahead and hit enter. And that blocks PC3 from server 1. Scroll down here to that took care of step 3A. Let's look at step 3B. Enter the statement that denies ICMP access from PC3 to server 2, which is identical to the statement above it, except now we're going to deny a destination of server 2. So we can up arrow here because it's the exact same statement. And once again, when we scroll up and look at our addressing table, we compare addresses. It's the second octet that's different here. We got to change the 101 to 103 again. So back in our CLI, we left arrow over to where we find the 101, change that to a 103, hit enter, and that enters in that last access control entry in our named access control list. And on to step 4. Step 4 says, by default, an access list denies all traffic that does not match any rule in the list. That's that implicit deny all or deny any at the end. Enter the command that permits all traffic that does not match anything. And so when we look at all 8 of those statements we just entered in, if it doesn't get denied by any of them, we're going to let everything else through. Now, in order to do that, we have to explicitly put in, we're going to permit anything to go through. And so after we did our last deny statement, now we can put that permit in. So it starts off with permit, and we are dealing with looking at the IP traffic because that's what we filter out. We filter out some of the IP traffic, right? HTTP, HTTPS, and FTP, but we want to allow everything else to go through. So it's permit IP, and then I'm going to put a space question mark, and we're looking to permit anything else that makes it down through there. And here we can use the keyword of any. Put another question mark in there and see the destination. So the first one was the source. We're going to have any source, so that's equivalent to entering 2 quad zeros, one for the network portion, one for the wildcard mask. Now we're looking to put the destination address in here. Once again, we want any destination. We want to allow all traffic through, so we can use the keyword any. And the keyword any is once again equivalent to 2 quad zeros, one for the network portion, one for the wildcard mask. So we have the keyword of any. So our statement to let all traffic through when it reaches here is permit IP any. That'll let all traffic through. Once you have that, you can hit enter. That adds that ACE access control entry to the bottom of our current access control list, that named extended ACL we're creating. Okay, step 5. Verify the access list configuration before applying it to an interface. Okay, so we're going to verify that. Make sure there are no typing errors and that the statements are in the correct order. To view the current configurations, use either the show access list or the show running config command. Well, let's go ahead and use both of them. So right here, we are currently in the mode to configure our extended named access control list. We have to type out exit once, type out exit twice. That brings us into privilege exec mode. From here, we can do the show access -list statement, and it'll list out all of our access control lists and the associated access control entries in there. Here we can see we have an extended IP access list named capital A, capital C, capital L, named ACL. Then we have our sequence numbers, what we're doing, are we permitting or denying, and then the exact information about that, what protocols we're using, the source addresses, and here we're going from a specific host to the destination addresses, and we're going to a specific destination, and then if we are filtering out anything. And so let's quickly compare, do they match? I'm seeing that they all match. I don't see any typos in here. It is looking good. So that one looks good. Let's go ahead and enter in the other command, show running -config. And then we can filter our output with sections, and I'm going to put the up and down line. That's the key above the enter key, but you got to hold the shift key. And then that begins with access dash list. That just filters out. That starts right here. I typed it in, and then it starts listing out everything from that first line where it finds that our filter requirement of access list, and it just prints out everything there. And now right here is our statements, our access control entries, and our IP extended access list, and it's named with ACL. So here's all of our ACEs, our access control entries. Looking again here, looking, does look good so far. That's looking good. And then here we switch between 101, 103, 101, 103. And then we have our protocols 80, 443, 80, 443. Notice here, we did type in the number 80. It converted it into those commonly known names for those layer 4 protocols. So it took port 80 and changed it to www. Okay, that looks good also. Difference between these two outputs. We have sequence numbers up here when we do the show access list, but doing the show access list does not include any remarks. Down here, it shows us the actual lines in there, and it would show us the remarks if there was any. Up here, when we do the show access list, the big thing here is we have the sequence numbers. With having the sequence numbers allows you to change one of those sequence numbers or insert another ACE between two sequence numbers. Okay, part 1 is done. On to part 2. Apply and verify the extended ACL. Traffic to be filtered is coming in from 172.31.1.96/27 network. And so that is this network right here. So right here is that number, but that includes all of these devices. So it originates here on this entire network, all the way up until this interface. And then it's destined for remote networks somewhere on the internet. Appropriate ACL placements depend upon the relationship of the traffic with respect to RT1. In general, extended access lists should be placed on interfaces closest to the source of the traffic. So if our traffic is generated right here on this network, right? Our traffic is generated here on this network on the left. Our access control list is on router 1 right here. Which interface on R1 is closest to the source of the traffic? That would be this interface right here. That'd be this interface. Now, to figure out what that is in Packet Tracer, I'm going to click in this window to make sure it's activated. So I just click now. I'm going to mouse over this green triangle, and then it's going to pop up and say this is the gig 00 port. So right here, the gig 00 port is where we want to apply this access control entry. Okay, part 2, step 1, apply the ACL to the correct interface and in the correct direction. In an actual operation network, an untested ACL should never be placed on an active interface. This is not a good practice and can disrupt your network. So you want to test this access control list out before you apply it. Hopefully you have a test environment or some extra equipment you can set up, but you don't want to put it on your live network, because if something is configured wrong, you will cause an interruption in your network. So we have a question here. On which interface should the named ACL be applied, and in which direction? Okay, we already talked about it should be applied to this interface, which was gig 00, right? And so if we apply it here, is it going to be for traffic coming into that interface, into the router for our inbound traffic, or is it going to be applied to traffic going out of the router, out of that interface, outbound traffic? Well, we want to filter it on inbound traffic, so the direction will be in. So what interface and what direction? It'll be interface gig 0/0 for inbound traffic. Enter the configuration commands to apply the ACL to the interface. Okay, so this is what we want to do. We want to apply the ACL we just created on interface gig 00 for inbound traffic. We have to go back into R1 here. In R1, I'm going to hit enter a couple times to give us a clean work area. We have to go into that interface first and then apply the ACL to that interface once we're in it. So we have to get into the interface of gig 00. Right now we're in privilege exec mode. We can go ahead and type config T, takes us into global configuration mode. Now we can enter into that interface. So it's interface G0/0. Once again, our prompt is now telling us we are configuring an interface. Now that we're configuring an interface, we can apply that access control list. The command here, once again, we start off with IP because we're dealing with the IP suite, and it's access group. Now it should, in my mind, it should be access list, but it's access group. And how I view that is the group of access control entries we are applying to that interface. First thing I'm going to do is correct my spelling of access. I got to add an extra C in there. So now I have IP space access dash group. Then you put either the name or the number, because we created a named one. We're going to put the name in there. And once again, that name is capital A, capital C, capital L. And then we said we are looking for our inbound traffic, and we specify the direction right here. So our command here is IP access group space capital A, capital C, capital L, space in. Once you have that in there, you can hit enter, and it applies it to the interface. That takes care of part 2, step 1. That takes care of this part right here. We come down and let's test out access for each PC. Access the websites of server 1 and server 2 using the web browser on PC 1, both HTTP and HTTPS protocols. Use the show access list command to view access list statement permitted or denied traffic. The output of access list command displays the number of packets that match each statement since the last time the counters were cleared or router rebooted. Okay, so we're going to use the show access list command. I'm going to go ahead and actually run that right now on our PC, on our router. But we're in the interface configuration mode. Type in exit once to bring us to global configuration mode. Got to spell exit correctly. Enter in exit a second time. That brings us to privilege exec mode. From here, we can go ahead and type in our show space access dash list command. And spell the word access right. I forget that second C all the time. And here is our access list. What we just looked at, we can see all of our statements here. Now, notice at the end of each of these access control entries, there is no matching. Right now, we haven't sent any traffic through our network, but let's go ahead and try from PC 1 accessing the web server on server 1 and server 2. So from PC 1. I'm going to close the command prompt here. How you close that is this blue line here that says command prompt. On the right side, there's this X here. I'm going to go ahead and close that. And what I need to do is make this window, I'm on the desktop tab, make this window for PC1 a little bit bigger. That gives us access here to the web browser app. Otherwise, it's just sort of hidden behind there. Go ahead and click on the web browser app. And it'll pop up our web browser. Nice, simple little browser. And we need to test both the HTTP and HTTPS protocols. So, right here, let's go ahead and put the IP address of server 1 in. We can get our IP address from the address table. Scroll up here. Here's our IP address for server 1. We just go ahead and put that right here in our URL in our web browser for PC1. 64.101.255.254. Once you have it entered, or once you've typed in the IP address there, go ahead and hit enter. And notice, because we didn't specify HTTPS to start, it just assumed we're doing normal HTTP port 80, and our result is timed out. So when we connecting into server 1 using HTTP, it timed out. Scroll down here. We are looking at from PC1, both HTTP and HTTPS to server 1 and server 2. Well, this gave us a timeout to server 1 using HTTP. Let's change this to HTTPS. So I just put the cursor right there, put an S in the right spot, so it's HTTPS :// and the IP address of server 1. And you can hit enter, or I'm going to click go. And we'll wait for it. That hopefully should time out. Now, if you notice, what I did here is I highlighted request timed out. And then when I went up here and I changed this, so now I'm going to change it back to HTTP. And I'm going to click go right now. It's still highlighted, but when it gets the response back, it changes to unhighlighted because it loads in a new page. The text we had highlighted isn't there anymore, so it's not highlighted. Even though it's the same text, it's because we're getting the same error. And so that's how you can know you loaded in two different pages. That's for server 1. Let's go ahead and do HTTP on server 2. Once again, to change between server 1 and server 2 IP address, we look at the second octet and change that from 101 to 102. Let's go ahead and make sure we're going to do HTTP to server 2, where we change that second octet from 101 to 103. I'm going to highlight request timeout, so that way I know my page has changed, and I can go ahead and click go. And we're going to wait for here. Notice it's still highlighted, It's got to go through the timeout process, and then bam, it's now unhighlighted. I didn't click anything. It reloaded in a new page saying we have an error because it's a new page. It's no longer highlighted. So I'm going to highlight it one more time. So that was testing HTTP. Let's go ahead and change that to HTTPS for server 2. That's second octet should still be 103, and click go. And we're going to sit here and wait. I'm not touching the remote or mouse. And then it loads in the new error because it's new. It's no longer highlighted. So for server 1 and server 2, HTTP and HTTPS, they are both blocked. So that's how our access control list should be working. Okay, let's go back. I'm going to minimize PC1 here. I'm going to go back to R1 here, get in the CLI, and I'm going to re-enter that show access list command. Now I can type it in again, or just use the up arrow. It puts in that command again, and I can hit enter. Notice how it looks this time. We still have all of our access control entries, but at the end of the line here, we have how many times it was matched. How many times did we match? And we did it a couple of times. So we are going to see that the number is increased. And if you notice, it is in multiples of 4. That's how the protocols go through their timeout features. But we do have some matches, and it did increase. Now, we don't have anything for FTP yet because we didn't try FTP. We don't have anything down here on ICMP because we didn't test anything on ICMP. Plus, we haven't gone, and once again, this goes from PC1 to server 1, or sorry, this goes from PC2 to our server 1, PC2 to server 2, and we did everything from server 1. Okay, takes care of step 2A, onto step 2B. Access FTP of server 1 and 2 from PC1. The username is Cisco and Cisco. So we're going to try from PC1 FTP. Now, how we do that is I'm going to click on PC1 here. I'm going to close our web browser. Close our web browser on the blue line here that says web browser. You go to the right side, click on the X. The FTP client we're going to use is actually a command line inside our command prompt. So I'm going to reopen up our command prompt here. I'm going to hit enter a couple of times just to give us a clear work area. And what we can do here is we can type in FTP and then the IP address of server 1 and server 2. I'm going to scroll up, get those IP addresses. Server 1's IP address is, I'm going to type it in, 64.101.255.254. Okay, I typed in FTP, the IP address of our server, and now it's asking me for a username and password. Scrolling back down here to confirm, our username is Cisco, and so is our password. So let's go ahead and type in Cisco here and Cisco. And now my prompt has changed from the C colon to an FTP prompt saying we have successfully connected to our FTP server. That's working good. Let's go ahead and quit our FTP client, typing in the word quit. Shows us we're closing, and now we're back to the C prompt. Let's go ahead and try server 2. Repeat that FTP command. I'm going to hit up arrow once. Actually, I had to hit it twice. And then you have to just change that second octet from a 101 to 103. So change it from a 101 to 103. What I did was an up arrow, left arrow over, got rid of the 101, and now made it into 103. Hit enter. It's asking us for username and password. This is a good sign. So it's Cisco, and then our password is Cisco. We have made our login. It's saying we've logged in. We've made our connection. Now you can use the command line to FTP to your heart's content. Right now, I'm just going to go ahead and type the word quit, end that session, and now we're back on our PC. I'm going to go ahead and minimize this. Let's go ahead and look at R1 again, and we're going to look at the show access list command one more time. So what I'm going to do is I'm going to up arrow once, hit enter, and notice we don't have any matches because this access control entry is from PC2 to FTP. We're on PC1, so we're confirming FTP works, but in order to have it match and be denied, we have to be on PC2. So we don't see any matches happening here. And I'm willing to bet when we go and ping server 1 and server 2 from PC1, we're not going to see anything there. Minimize router 1, open up PC1 again. Still in my command prompt. I'm going to go ahead and ping the IP address of server 1. Once again, that IP address, I can just barely see it right here in my window. 64.101.255.254. Eventually I'll get that memorized, but we're looking at 64.101.255.254. And now PC1 here is pinging PC1 here is pinging server 1 in the internet in the cloud. That successfully worked. Let's go ahead and ping PC3. All we have to do is change that second octet. So I hit the up arrow once, left arrow over, change 101 to 103. And there is our ping successfully working. I'm going to minimize PC1 here. Go to R1 here and repeat our show access list command. And notice our matches haven't done because we still haven't matched anything. Because our match for ICMP, which ping is only for PC3. So we didn't get any new matches here. Okay. Minimize the router 1 window. On to step 2D. Repeat step 2A to 2C. So that's the web browser, the FTP, and the ping for PC2 and PC3. Verify proper operation. Let's go ahead and take a look at PC2. Clicking on PC2, we're in the command prompt, but we need our web browser to do A. So close our command prompt on the blue line here that says command prompt. Click the X on the end and make the window a little bit bigger because technically right here is the web browser app. I'm going to make this window a little bit wider so we can see it. Go ahead and click on the web browser app and we can put it in our IP address. Let's go ahead and put the IP address of server 1 in there. That is 172. Nope, it's not 172. My fault. The IP address of server 1 is 64.101.255.254. And that works. Let's go ahead and try HTTPS right away on server 1. And I'm going to highlight something on that page so that way we can tell when the page changes. And so I changed from HTTP to HTTPS here. I'm going to click go. And notice how the highlight went away. That means we've loaded in a new page. That has worked successfully. Let's go ahead and try connecting into server 2 using HTTP. First, I'm going to highlight something and just randomly highlight. Then I'm going to go get rid of the S in HTTPS and then change my second octet from 101 to 103 and click go. When I click go, the highlight went away because I didn't click in the window. We loaded in a new web page, so that shows us that worked. So getting the web page through HTTP from server 2 works. Let's change that to secure web. Add in that S in there after the P. I'm going to highlight something to make sure the page loads in and click go, and it loads in that quick because it's allowed. It doesn't have to go through any of the timeouts. Okay, here PC2, I'm going to go ahead and minimize this. We're going to look at R1 quick, look at our access list. Notice it did not change. The matches here did not change any because right here we're just denying PC1. PC2 traffic can go through just fine. It's allowed through there with this last statement down here. And actually, if you do notice, our matches have went up. So between this time on our sequence 90 of the permit anything to this time sequence 90 of the permit anything, we actually went from 28 to 48. So we allowed that many web connections to go through since the last time we ran it. Okay, so that's our HTTP traffic. Now from PC2, we're going to FTP server 1 and server 2. Let's open up PC1 here. Close our web browser. Open up our command prompt again. Hit enter, and we're going to do the FTP again, and then the IP address for server 1. So we're on PC2. We're going to FTP into server 1. That is 64.101.255.254. Hit enter. It's trying to get there. This is what should fail. This is what the access control list is blocking. So it tried to open it up. We got an error opening it. Let's make sure we got the right IP address in there, 64.101.255.254. That's it. And then we're disconnected from the FTP server. We were not able to make that connection. Hit enter to bring up the C prompt. Up arrow one more time. Let's change that from 101 to 103. Server 1 to server 2. Hit enter. And we're going to try it. And once again, this should also be blocked because we added that filtering in. Now we have blocked that. We weren't able to make our connection there. I'm going to minimize PC2. Open up router 1. Repeat our show access list command. And now notice, the previous time I ran it, sequence 50 that blocks from PC2 to server 1 had no matches. This time, sequence 50, PC2 to server 2, FTP, we now have 12 matches. We now have 12 matches. Okay, but it didn't show. Oh, I typed in the wrong IP address here. Okay, the IP address I typed in here was 64.102. It should either be 101 or 103. Because it was 102, it didn't work. There was no FTP server there. Let's go ahead and correct it for the right IP address. So I hit up arrow once, I go over, I change the 102 to the 103, which is the IP address of server 2. Let's go ahead and try that again. And it's going to try. Our ACL should be blocking it. And we got disconnected. So we weren't able to connect in. I'm going to minimize PC2, click on router 1. And I haven't entered in the show access list right here, but this is what we're going to be looking at. We're going to be looking at 60. When I entered it incorrectly, I had a 102 here, so it's not going to show up as a match. But now the last time when I corrected it or entered it incorrectly, we're going to have some matches. Let's go ahead and repeat our show access list command. Look at sequence 60, and now sequence 60 as our 12 matches. Once again, up here, when I entered it incorrectly, it didn't match. Now when I entered it correctly, we have our matches. Okay, that takes care of PC2 to FTP. And the last one here is we're going to do PC2 and ping server 1 and server 2. So open up PC2. And we're going to ping. And then our IP address is of 64.101.255.254. That's server 1. That should work fine, because we're not blocking that. We're blocking it from PC3, not PC2, which we're on right now. Let's go ahead and change it to the server 3, or server 2 IP address, which is 103 in that second octet. And those should work also. Okay, I'm going to minimize PC2, open up router 1. I haven't increased anything, but we didn't get it. We shouldn't have any more additional denies, but our matches should go up. So I'm going to go ahead, repeat our show access list command. Notice we have no matches down here on the FTP, but on our permitting anything, we now have increased from 60 to 68. 60 to 68. That takes care of step 2 for PC2. Now we have to do step 2 for PC3. Repeat the HTTP, HTTPS, the FTP, and the ping. So I'm going to minimize router 1 here. Click on PC3 here. First thing we're going to do is go into our web browser. Close the command prompt app here. Make the window a little bit bigger, going right to left. Click on the web browser app. Opens up our web browser. We're going to put in the IP address for server 1, which is 64.101.255.254. Click go. Loads in our page. Once again, it should load because we are allowing it through. We are only blocking HTTP and HTTPS on PC1. We're on PC3, so that should go through. I highlight something that allow me to see when my page changes. Let's go ahead from HTTP to HTTPS. I put an S in there and I click go. And notice how the highlighting went away? That means I loaded in a new web page. So HTTPS on server 1 is working. Let's go ahead and try HTTP. So get rid of the S. On server 2, you change that second octet from 101 to 103. I'm going to highlight something on that page so I can tell when it changes, and I'm going to click go. And it's done that fast because it's allowed. We don't have to go through the timeouts to get our errors. We're successfully able to see that. Let's check the secure version of it. HTTPS, still to server 2. I'm going to highlight something and click go, and it loads it in. It got rid of the highlighting because it was on a new page. So HTTPS is working. I'm going to minimize this. Go back to router 1 here. We shouldn't see any increases here for our web traffic because we are looking at, oh, that's interesting. Serial interface went up and down. On a new neighbor. Oh. Okay, so we're only filtering on PC1 traffic and we're on PC3, so we shouldn't see the matches for denying going up and down, but we should see the matches for our permit anything going up. So our matches for our permit anything is 68. We should see that increase. So let's go ahead and repeat our show access command. And we can see here that the matches up here didn't go because we didn't match anything until we got down to sequence 90 where we're permitting anything, and now we're up to 88. We were 68, now we are 88. And that's working as expected, allowing PC3 to get to the web server. Now we need to look at our FTP from PC3. Here's PC3. Close my web browser, open up my command prompt. Once we're in our command prompt, we type in FTP, then the IP address of server 1, which is 64.101.255.254. Hit enter. And now it's asking us to log in. Once again, this is a good thing because we are allowing this through. We are only blocking FTP on PC2. We're on PC3. So go ahead and enter in the username of Cisco and password of Cisco. We made our connection. We can do whatever we want in there. When we're done, we type quit, close that connection, and we're out. Let's go ahead and try FTPing to server 2. I hit up arrow twice. We can left arrow over, change 101 to 103. Hit enter. It's going to try. It's asking us for our passwords. Let's go ahead and type in Cisco and our password of Cisco. We're logged into the FTP server, so we made a connection. Once again, that's following what we have for our access control list. Go ahead and type quit. And it brings it out. I'm going to minimize PC3, go back and look at router 1. Router 1, for our filtering on FTP, which is right here, that shouldn't increase because we're only filtering from PC2. We were on PC3, which means our permit any matches at the bottom should increase when we repeat our command. So up arrow ones, hit enter, and notice our FTP still stayed at 12. That's what we had right here. We have now stayed at 12, but our matches previously were 88, and now we're up to 110 because we actually did establish the connection and send all of our passwords. It made a big jump, but it did work, and so it did increase, so we can see where our matches are happening. That was for FTP. Last thing we have to do is ping from PC3 to server 1 and server 2. I'm going to minimize the router 1 window, click on PC3, and we can go ahead and ping our server 1 address, which was 64.101.255.254. So from PC3 to server 1 on our ping, our ICMP, it is saying that we sent 4 packets, we received 0, we lost it, we're at 100% loss. This IP address, which happens to be on our router here, happens to be right here, it's saying that our network can't be reached. Our access control list is actually blocking that ping from going through. We can't reach our destination. Okay, that was a ping for server 1. Let's go ahead and ping server 2. What I'm going to do is up arrow once in my command prompt window, go over, change that second octet from 101 to 103, and hit enter. If everything works out, the ACL should be blocking that from going through, and that's what we're getting. We're getting a response back from 172.31.126. That's this router here. That's our router where our ACL is, and our ACL, and that router saying is destination unreachable. It didn't have to time out. We got our responses back fairly quick because it looked and saw in our access list, we are blocking traffic from PC3 to server 1 and server 2. So we get the destination unreachable. Okay, let's minimize PC3 here. Let's go back to our router 1 here. And this time, we should see a match here on these last two, because these last two, source of PC3 destined to server 1, looking at anything ICMP, which ping is. So we should see an increase here in sequence 70, and we should see an increase in sequence 80, and that was once again PC3 to server 2, and our permit any should not increase because they all should have been blocked there. Okay, let's go ahead and repeat that command. Now, up here originally, sequence 70 had no matches, sequence 80 had no matches. Down here, when I repeated it after we did the pings, we now have 4 matches. Those were the 4 pings sent out from each time. Each time you type in ping and it does it, from a Windows operating system, it tries to ping 4 times. So we have those 4 matches, and our permit anything did not increase. It was 110, still 110. We blocked all the pings. That's all we did. And so now we can see how these counts increase in our access control list when we do the show access list. That was Packet Tracer Lab 5.4.13, Configure Extended IPv4 Access Control List Scenario 2. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.